logic building we had discussed till this perfect number, I believe, right? So count of factors and perfect number. Sorry, not count of factors, sum of factors and perfect number. Let's continue today. We continue with few more logics and then just jump to the next topic, that is for loop. After for, then again we talk about range functions, types of ranges, and then we do some programs on range as well. And then jump to the once this is done, we move to the next topic, that is data structures in Python. Okay, one by one, we start discussing all this. So now the next topic is this one. What is it, friends? Count of factors. So we had discussed about while loop in the last class. So what is while, the syntax of while, and how to create programs with while, all that we had discussed. So now let us discuss about count of factors. How do we find count of factors and primer composite, all that, and then we talk about for loop. So if you want to find count of factors, so how do you do that? Already we had a discussion in the last class, right? So let me just share my screen so we can close all this. We had discussed till this perfect number. Same thing, same logic. It is an extension to the last, I mean, whatever we had discussed about a perfect number or something like finding sum of factors, something like that, whatever we had discussed in last session, it is almost an extension to the previous logic. So here I'm just adding a new program, new Python file, and then I can say count of factors. Enter. Okay. Just a minute. Yeah, count of factors. So now what do we do again? We have to declare a number. So for finding some input number, and then you can take it from keyboard, convert it to integer, something like input of, okay. And then generally, right, what to do for finding count, you can take a variable and initialize it to 0. So by default, we set it to 0, so that when some we try to iterate, and then we see every time our loop variable divides this input number, then that is a factor. Then we increment count. That is the logic we apply. So what do we do right now? While this is the one, just take a loop variable, something like I just name it as a loop variable itself, and then set it to 1. This has to iterate from 1 to that number, input number. So you can simply say loop variable less than or equal to this one, input number. So you can take this and then colon, and then what you can do now, we just need to do a validation. What is that? That input number divisible by that loop variable. If it is divisible, equal to, so equal to 0, then simple, we should increment the count here. Right, sorry, count equal to count plus 1. So this is the logic we should follow, friends, when you are finding count of factors. Okay, just iterate the loop until that number, and then divide that loop variable. Each time loop iterates, divide that loop variable, that input number with loop variable, and then if it divides properly, then increment count. That gives you count of factors. That's all we are done here. And finally, just small thing is just increment loop variable as well. Loop plus 1 equal to, that's all, loop variable plus equal to 1. This is the shorthand notation. You can apply this. Now finally, you can just print the result. What is that? So here, count of, you can say count of some input number, count of factors of input number is. Again, you can simply say simple count, just pass the count here, that is enough. And this is how we found count of factors. Then we implement again. This is again a base logic for prime or composite. From this is almost the core logic for validating prime or composite. But of course, first let's test this and see what is the output for this. So this is for finding count of factors here. Now right click and run this and try to provide input from keyboard. You just give, just for testing purpose, choose 6 here, no problem. You can choose anything, friends. It's not like it should be 6. It's up to you. Now 6 has 4 factors. This is perfect output because 1, 2, 3, and 6 are factors of 6. So this is working as expected. This is a perfect thing. We don't have a problem with this logic. So this is working fine. Testing is successful. So this is how we find count of factors. That's all. You can give any number now. It just gives you count of factors. You give 100 and you can see 100 has 9 factors. And when you print them, if you want, you can print and see as well. It's not just we can just only find count. If we are interested, we can print that loop variable, right, and see what factors are there. Okay, friends, this is the idea about count of factors. The next one is almost this is the core logic. Once you understand this, doing prime or composite is very simple. Somebody asked me in the last class, how do we find prime or composite? Generally, for finding this is one thing is using loop is most recommended. Right, there are different ways to validate, of course, to find prime. But one way I'll show you. You can try multiple ways. You can check in ChatGPT or Stack Overflow, different ways of finding prime. Right, so we can close this and even this as well. Come here in the loops and then say new Python file. Just name prime underscore composite. Okay, enter. So now we use the same logic to implement prime or composite. Only thing is we just need add external check to find prime or composite. So you can add a comment if you want. Generally, I told you this when we are doing in our last previous sessions, prime or composite. Most of you also might be knowing the importance of comments and code hygiene, everything. Just make sure you follow all that. Okay. Next one. How to do validation? This is a validation. Only thing I just need to add one more validation block to check if a number is prime or composite. How do I do that? Here just, right, this is something which we are we are being taught about prime number. It has just only 2 factors, 1 and itself. Now we are already finding factors here. This is something an easiest way of understanding a logic. We are finding factors and the count of factors. And prime number has always just 2 factors, 1 and itself. You take 2, 3, 7, 11, 17, all these numbers, right? So this kind of number just has only 2 factors and such numbers are prime numbers. So the easiest thing is once you found, almost our job is completed. The core logic is completed. And just to check if number is prime or composite, we just need to provide a validation here. We just need to add a validation block here. That's all. So if count equal to 2, then it is a prime. Printer, you can simply just add in double quotes. So maybe you can just take that input number is okay, prime. That's all. Else, maybe if you want to add some composite thing, just take same thing and you can take this print and add and the else block. Just change that to instead of prime, it's composite. And this is how we create prime or composite. So this is the idea, friends. Got it, right? Because somebody asked him in the last class, so I'm just doing this as well. So small thing is there is some external noise coming. I'm just muting all your this thing. Any question? Then definitely we'll discuss in the once they are at the end of session. So let me run this now. Just give and put some 7. 7 is prime number, right? We should get count of factors of 7 is 2 and 7 is prime. You can see here. Suppose we are just doing a straight validation. Suppose 1 is there, even if you want to validate just for 1, it is neither prime nor composite. If you want to add that validation as well, you can put it. If it just have, if count of factors is less than 2, it is neither prime or nor composite. Only one have that. Just only one has just one factor. Okay. So remaining all at least have all primes have two factors. So if you want to add even that validation, you can add that, friends. It's up to you. Okay. Now you take one more number, give some 10, and you can see 10 is composite, no doubt. So this is how we validate prime or composite. I'll do one thing. I'll share this code with all of you so that you can also use it for practice. And let's see this. Let's see this. Add this here. Insert. Okay. And next program is this. Let me add prime or composite as well. Okay. So let me share this code with you. Okay. So this is about this one. Still anything with this we can discuss, no problem. Maybe we'll keep that for end of our discussion. We'll discuss that end of our class. Sorry. So this is the idea about this one, friends. So there are other things like there are, if you want you can try a few more logics on this, which generally useful for logic building thing. How to deal with different ways of working with logic. That's all. So, but these days, of course, we don't have a big issue for working on logic. But only thing is we just need to work on a couple of problems automatically that gives some clear picture. That's all, friends. Next after that is maybe you have these things. What is that? Suppose you have a number like this, printing digit by digit. These are something which you need to understand so that somewhere in the future when you are implementing certain logics, so it helps you to quickly understand what you are doing in the code. So printing digit by digit, sum of digits of a number, that is one more thing. Sum of digits. Suppose you have 1, 2, 3. It's not, if not 1, 2, 3, any number with right more than 2 or 3 or any number of digits. Sum of digits of a number, that is one more thing. Okay. And the palindrome, Armstrong. These are another set of logics which has a different way of what is that? It is also worked on. These are also implemented on loops, but slightly the way we increment loop all that using this kind of logics is different, slightly different, not the way we regularly do. Okay, what do we do in this kind of logics? We'll quickly check on this and jump to the next thing so that this gives you a complete cycle of logic building thing. So what we do here now, let's quickly check on these things. What is that? 1, 2, 3. Printing digit by digit. So how do you do this now? Printing digit by digit. It's very simple. You take this number, you come to this, create a program, new. So here, printing digit by digit of a number. These are all something which gives you a kind of this thing for logic building. That's all, friends. So from tomorrow, I think we jump to the again. the core concept, understanding of core things. But this finally gives us overall picture about how loop iterates, how we can apply logic, play with logic, what are different ways of iterating loops, all that. So it covers different scenarios of thought process or this logic sessions. So now printing digit by digit, you can take again same an input number or value, anything you can take it friends and convert it to integer by applying int here as usual, use input method. Okay, then so this is nothing but your number. Assume that that number is this example. You can take it as 1, 2, 3. Just an example. You can input anything of your choice. I'm just taking it as a test case, which is 123. Now after that, the loop thing. How do you iterate this? We don't. This time we iterate in a different way. What is that? Before this, you do one thing. Small thing is take a temp variable, copy this input number. This is important. Now you start working on this input number. What is that? If input number greater than 0, until it becomes 0, you should keep on iterating loop. And this is your number. And if you want to get digit by digit, in this, the best thing is divide this with 10. So what is that we have to do here is, so the simple thing is you take 1, 2, 3, divide with 10. This is the operation you have to do, friends. So this is something you need to understand when you start or when you begin programming or coding. Okay. So you see this. So 10, how many times it will go? 10 12s. This is an integer division. Here we are performing integer division. 10 12s, we get 120, and then remainder is 3. See there. When we do the first division, first means what? To extract each digit from this number, we should perform division here and get remainder. You can see first time we got 3, right? So from 1 to 3, we are able to get 3 first. Similarly, once we extract 3 from 1 to 3, we have to pass this 12 as input for subsequent operation, means next operation or next iteration. So again, 12 should be input for next iteration. So what do you do right again? So you simply again take 12 as input for next iteration. This is how logic works, friends. Right? And again divide, process same. Divide with 10. Okay, 10, how many times it goes? 10 once 10. So again, you divide, you come here, just get the remainder. What is the remainder? 2. Now we extracted 3 in the first iteration. Now again we extracted 2 from second iteration. And again we are left with one more digit here. And this acts as input for next iteration. This keeps on going, friends. Suppose how many iterations in this kind of logics we are going to have. It depends on number of digits in that number. Okay, in that input number. This if it is having 3 digits, it iterates for 3 times. 4 digits, it iterates for 4 times. N digits, N times. Simply speaking. So now we extracted to one more iteration we do. What is that? Again, we divide 1 with 10. Okay, so 10, how many times? This is integer division, right? 10 0 0. Sorry, friends. So then if it is 10 0 0, right? Because it is integer division, it won't take fraction here. It just round it up by 0. So 10 0 0. Remainder becomes what is it, friends? 1. Now this is the simple tracing for the logic. And this gives you a overall idea. Once your quotient becomes 0, you should stop iterating the loop. That's all. Till then, until once we start with that number, until the quotient of that number becomes 0, we have to keep on iterating loop. And how many iterations do we have here? It depends on number of digits in that given number or input number. So finally, once the quotient becomes 0, So we have to stop that. By that time, you can see we are able to extract all the digits from that number. We got 3, we got 2, we got 1. So this is what we have. And from that, you do whatever you want. You can find palindrome, you can implement Armstrong or anything. But first thing here is understanding how to extract each digit from the number, how to iterate loop when you have this kind of logics. And what is the core logic you are applying here? The core thing here is dividing by 10 is the actual hint here. The core thing is dividing by 10, both for extracting remainder and getting this quotient. If you want to acquire quotient or if you want to get this remainder, anything, we have to divide that number by 10. That is what we should do here, friends. You got it right. So what do you do right now? So let's just quickly do that. So until this number becomes 0, you can say this. You have to keep iterating. You don't need to start here. We don't need something, a separate loop variable this time. So here we just use the input itself for validating condition here, that input number. So now once we do that, we should get reminder. So R equal to, or you can directly say reminder, no problem. Input number to get reminder, divide with 10. Okay. So this gives you reminder. So every time you need reminder, right? To get that reminder, divide that input number with 10. Then if it is just printing digit by digit, you don't need to do anything, just print that R. R is our actual variable which stores digits. So just print R. And finally, so here what is it? To increment loop. This time we do a different way of incrementing. So what do we do, right? So we have that input number equal to input number /10. This is what we should do. You got it right, friends. So you have to again get the quotient and assign that quotient again to the same input number. Suppose in the first time, in the first iteration, if number is 123, then that is replaced with 12, and that is replaced with 1, and that is what this is doing. And this division for quotient, this is acting as incrementation. I hope this is clear, friends. So this is how we try to extract digit by digit. So this is the core logic, and I think we had a very detailed tracing of that logic as well. So this should give you a clear idea in these kind of scenarios how to perform logic this thing. I hope you are clear now. Now finally, what is that I should do? We don't need to do anything. We did whatever that is needed. That's all, friends. Okay. So now right click and run this, and then just provide input variable. So input value, something like 1, 2, 3. You can see 3 to 1. You are able to extract digit by digit. Okay. That's all, friends. So this is how you try to extract digit by digit using this simple loop scenario. Okay. Next, you can give any number. Suppose I give a 4-digit number 1, 2, 3, 4. Now you can see 4, 3, 2, 1. So this is the idea. So once you understand this and applying all these logics, what is that? These logics, friends. Sum of digits of a number or palindrome or Armstrong, anything is simple once you get this clear picture. So suppose you have a number. I want to find sum of digits of this number. So what is that? If 123, I want to find 1 plus 2 plus 3. I want to do that. If I want to do this, what is that? Again, same thing. Just we need to do a little addition here. Just doing a sum operation in this. This almost covers majority of the logic. Only thing is we are able to get digits here, and that digits we just need to add. That's all. We need to perform a sum of iterative sum. That's all. And we know how to perform that iterative sum. Okay. So now what do you do right now? You can add one more program here. So we can work on this. What is that? Sum of digits of a number. So right click on this new and then Python program. Okay. New Python file. Sum of digits. Okay. This anyhow, let me share this code with you before I move to the, this is printing digit by digit. Printing digit by digit. Where is it? Yeah. Let me share this code with you. Maybe you can try this. I'll just give a minute or two time, just just for your validation, and then I keep moving. Sum of digits. I told you the logic here, friends. I have explained the logic. This is how we should do. If you think you want to give a try, so just a minute. If you think you want to give a try, see this one. Just find this. You almost have the logic here. I just shared the code as well with you. So this one, printing digit by digit. And to this, we just need some few more statements to find sum of digits. That's all. That iterative sum, we should add it. If you want, you can give it a try. Just take a minute and try it, friends. Okay. So this is the idea. So copy this now, paste that code here. Just give it a try. What is that you should do here in this program to find sum of digits? You can just say,
Excuse me, here one little bit confusion. What is the
yeah,
temp? What is the temp doing? Not required, right? Temp.
this program doesn't need that, of course. See, I just only mentioned that, but this you can remove this, friends. This is not needed. Let me just share this with you. Just a minute. Not to have that confusion. Yes, somebody brought that. Thank you. We'll do one thing. Printing digit by digit, right? So let me do. This is not needed. This is, we can add this when we do logic for Armstrong or palindrome. In that scenario, we can preserve that input value. But for this simple operation, we don't need to add copy the value to the temp. Just as a prior thing, I just added temp there, but that's all. But no need. Let me share this with you. We can remove that to avoid confusion, like as some of our friend asked me. Let's not have that confusion till we discuss that palindrome or Armstrong, friends. Okay. So this is
Sir,
done.
we are unable to see the chart. I am unable to see the chart.
You are unable to see the chart. Just a minute, friends. You are not getting it. Oh, let me just see. I think I didn't send it. Now, can you see it now? You should get it. No problem. I'll just reshare all those code once.
Yeah, yeah. We can able to see all the chart.
Sorry,
Thank you.
sorry. I forget to print on that. Just hit on that submit. I mean push button. I got it now. Thanks for the reminder. I'll share them all that whatever we had just discussed so far. Yeah. Now you should be getting all those, right? Yeah. So what is that we did? We did prime or composite. Okay, let me share this count of factors. One more is that. Let me share these as well. Thanks for reminding. Of course, you have all that code in the this thing, and then prime or composite. Copy this, and then
Someone is accumulating, consolidating all these programs.
yeah, see that. Okay. So so I think Shiva sir is asking question. Anyone consolidating these programs? Okay, no problem.
Okay, yeah, we'll
We,
do that one. Mm.
yeah, else I'll share this list from here itself, Shiva sir.
Yeah,
That
yeah,
can be
okay.
used.
Yeah. Mhm.
Yeah. So I think where we are, this is, I think I shared all programs what we had discussed so far, right? All logics, count and prime, and then printing digit by digit, and then Sum of digits, we are yet to start. Okay, I think we shared, no problem. Digit by digit is done. Then sum of, not sum of, sum is done. Sum of digits, yes. So this is a very simple, friends, here. Only thing, this core understanding is important. This is why many people have a little bit of fear. If you understand this logic in a proper way, this logic building, you don't have that fear thing. Right. So next after this is finding sum of digits. We know how to print digit by digit now. Sum of, I just put it as sum of digit. Okay, equal to, set it to 0. This is this, you, even while you are working on your data engineering, this keeps coming to you, friends. Trust me, because I worked in big data, right? So this kind of iterative sums or iterative products you keep on doing when you are playing with your data engineering. Even though it is data, this logic is something which you need, right? So that's what, friends. Sum of digits, and then here. So here, make sure you don't again repeat the program name here. See, you can see my program name is sum of digits. I name this variable as program sum of digit. Again, if you try to put the same name here, there might be sometimes it might get into some issues. So make sure don't reuse your program name as variable names or something. Again, that is a simple tip, friends. Quick tip. Okay. So what do you do right now? Here, instead of printing, the best thing to find sum is this sum logic. All of us know, right? Iterative sum. Sum of digit plus. Okay, you can do it in different ways. Plus equal to, you can say R. Means what it is? Sum of digit equal to sum of digit plus R. And finally, what this is as simple as adding sum equal to sum plus some I or something. This is an getting iterative sum. So finally, what you have to do? You have to print it and then just say double quotes. So what is that? The sum of digits of, you can, if you want, you can add that input number, whatever it is, our input is, again you can add this sum of digit. So that's all, friends. So this should give you sum of all digits. You can take any number because these are simple things to validate. Sum 4, 5, 6. 4 plus 5 plus 6.
I think
Should
in
be,
print you missed the sum.
yeah. And this time you can see this is where we need input number. So sorry, this is where we need temp. See this time why input number is giving us 0, because by the time we completely iterate this while, as discussed in this tracing, we had a very detailed tracing. You can see here, this is our input number 1, 2, 3, and every time, and this is, and we are iterating this itself, and we are updating this input. You can see here, we are incrementing input. Initially, it will be 123. After that, it will be 12. After that, it will be 1, and finally, it will be 0. So that's why what we did, we assigned that. Now this time, if you want to print input number, then assigning to temp is something important, friends. Okay, assigning your input number to temp is important. Even though input number is modified, still original value is preserved inside this temp. So now this, if you print temp here, you get the actual 456. You don't get 0. Now run this. So this is the purpose of temp, friends. You got it right. Just give repeat 456 again. This time you can see the sum of course, the sum of digits of 456 is 15 here. Right click and run this, friends. See here 456 and then enter. You can see here, friends. Perfect, right? 4 plus 5 plus 6 is 15 without any doubt. And this is the importance of temp in this kind of scenarios. If you want to preserve that actual value, but because by the time loop iterates, input number becomes 0. That is very clear. It is evident from this discussion and tracing. And still, if you want to trace, you put a debugger and then right click and then say debug, because this is something which we keep doing regularly, right? If you want to quickly trace it, give some number, something like 3, 4, 5, enter. And you can see here, just to see if it is a 3-digit number, this loop iterates for 3 times. And you can see here, by the time you come here, you can see that input number has 345. And then next step, you can see the first iteration. You can see we don't even put cursor. It's by default showing all your values. So this input number has 345, even to the temp that 345 is copied. And this is assigned to 0 and R is assigned to 5. It is trying to extract the first digit from this 345, that last rightmost digit. And again, after that, it extracts 4. After that, 3, something like that. So now again, you can keep on. Now you have sum of digit has something here. In the first iteration, it would be by default 5 itself, because 0 plus 5 is 5. You can see, you can keep observing sum, like to see how this total sum is coming here. So you can check on this. Okay, again, next iteration, you can see this input number starts with 34. You can see here. After that, it will be 3. So like this, you can keep on tracing, friends. It's very simple. Put a breakpoint and then just run the code in debug and see how it's going on. Now this time we extracted 4 and we add that 5 plus 4, that is 9. And then you can see 9 got updated. Again, input number, extract that quotient here. That quotient here is what? From 34. So next, for the next iteration, it would be what? So it would be 3, I believe, right? So now you can see that this is updated with 3. Again, same thing, and it keeps going. You can see here again that 9 plus 3, it should give you 12. That's what we got here. And again, we extracted that last. Even this is done. Addition is done here. And last thing is, we have just one digit. We divide with 10. And finally, remind this quotient becomes 0. You can see here. So 0 greater than 0 is false. Iterating loop is terminated once that input number becomes 0. And you can see that the execution is going to stop now. You can see that execution of loops terminated, and finally it's printing this print statement. That's all, friends. This is how you can quickly trace your program by adding a breakpoint, and you can verify in each iteration what are the values it is generating. And that's how you can try to get rid of any doubts or anything with values or your, I mean, how the code is getting executed, all that. So that is the idea. So we are done on one more core logic. We are done with sum of digits. Let me share this as well with you. In this case, temp is important, because if you want to print input number, then definitely we have to preserve it to temp, even in this code as well, printing digit by digit. If you want to print input number, here we are just printing R, that's why. But if you want to print that input and see, then assign it to temp. So that temp is something which has actual value. And by the time this loop iterates, this input number becomes 0. This completely iterates. Once this loop completely iterates, input becomes 0. So that is just a quick tip for you, sharing this code with you. Code snippet, run this, set this. That's all. This is about printing digit by digit. Next, after that, sum of digits is also done. Sorry, sum of digits is done. Next, logic. And here, palindrome and Armstrong are almost, once you know these things, these core things, printing digit by digit, sum of digits, working on palindrome is nothing, friends. It's a simple, again, a kind of doing iterative sum, just by again multiplying it to 10. That's all. So palindrome. Palindrome means what? Simple. You reverse a number. Suppose you take 121. When you reverse 121, you get 121. So this is a palindrome. So similarly, you take triple true, you reverse this, you get again same number. That is palindrome. Similarly, suppose you take 123, you get 321. This is not a palindrome. So something like this. So what, and to do this again, to implement these kind of logics, the basic is this getting digit by digit or finding sum of digits. That is something which we apply. So just create a simple program, right click and then new and then say here, what is that? Palindrome. Okay. Enter and just you can close this. And then now what do you do? You can again apply the same steps, like, just get a input number and remove this. If you try to import this, you might get unexpected output. So remove this. This is a different program altogether. Input number equal to int of sum input. Apply input function. Then after that, while again, before that, do one thing. Assign that input number to a temp variable. Okay. And then after that, while you have to keep doing this, what is that you should do? Input number greater than 0. And then get the reminder equal to input number percentile 10. Then to find palindrome, we need a sum variable here. So you can say sum value, just assign it to 0. Take a sum variable, additional variable or resultant variable. This is for, but doing a pre-initialization, right? So how do we apply here? Sum value equal to sum value into 10. This is what we should do when you are doing palindrome. To reverse a number, the simple logic is when you divide by 10 and to reverse it, multiply by 10. This is what we learned somewhere in our school days. So that is what we are doing here. Every time we iterate, we again multiply that with 10 and add that reminder to this. This is the simple logic we should apply. It is almost doing some iterative sum. Just only thing is we are just doing a product with 10, multiplying that sum with 10 here. And this reverse the value. That's all. So finally, one more thing is that input number equal to input number / what is it, friends, at 10. So we are done with this. And now this is about reversing a number. If you ask me, this whole logic is doing a reverse of a number. Suppose if you want to print it and see, print, here you can see the reverse of a number is. Okay. So here you can directly print what? That sum val. That sum val has the reverse. Okay. If you print it, then you can see the output cell. And if you want to again see that number, instead of this, you can simply do what? Use this here, print them and say is. And this should give us proper values as well. So run this and give a number here, something like 1, 2, 3. And reverse of 1, 2, 3 is 3 to 1. You can see here. And this is reversing. And if this code is able to reverse the number, then we are almost there to check palindrome. To add palindrome validation, it is just a validation. So only thing is we just need to add an if block here. What is that? So this is the palindrome validation. This is a simple condition check. We should add to the existing one, this logic, to the existing logic. So what do you do right now? What do you do? If that temp, we should compare with temp, don't compare with input number. And initially in the beginning, for a couple of times, we try to compare with input number, but we don't get output. And finally, we come to know that we should copy this input number to some temp variable. So all this comes with practice, friends. Okay. Temp equal to what? So this some value. Maybe if you want, you can name it as reverse or something as well. It's up to you, friends. Okay. Copy this some value. Compare it with the temp. Okay. And then colon. And you can now add print here. What is that? Print. And in you can use the F string. So that temp is, you can just say temp is palindrome. Sorry, palindrome, right? Yes. Else, not a palindrome. That's all. You can simply copy this and add this here. We can say is not a palindrome. And actual, all this, your logic part, everything is in the loops itself, friends. So if you ask me or anyone, any developer, majority of the coding lies in this looping only. Just loop is something heart of any program. Almost all we achieve most of your development thing with looping. Without looping, we cannot imagine a bigger coding. So run this now. Give some number 1 to 1. 1 to 1 is same, right? When you reverse 1 to 1, it would be same. So it is showing as palindrome here. Okay. Again, give one more input value. Give 1 to 3. 1 to 3 is not a palindrome. You can see here. And it's perfectly validating. So everything is fine. We tried to have 2 test cases and both test cases are working as expected. So code wise, we don't have any issue. This is working as our expectation. So we can, so this is about checking palindromes. If a number is palindrome or not. Okay, so I'm sharing this with you again. So let me share this code with you. I hope this is clear for all of you friends to check if a number is palindrome or not. Got it right? So next thing is what? Armstrong. Armstrong is almost similar again, but it has a slight different approach of implementing Armstrong. I'll just give you a quick idea about Armstrongs. Okay. But before I jump to that, this is clear for everyone, right? So I'm closing this here and just giving
And
you.
and
Yes,
how
please.
to do that? How to do that in string in palindrome?
String you can do simple, right? You take any string and reverse it. Let me just show you because we didn't discuss strings, so I preserved that for adding that palindrome when we discuss string topic. Is that
Yeah,
okay?
yeah. We
Or you
we
want?
can do that future. Yeah. Thank you.
Yeah,
Yeah,
you
we can
can.
discuss that one. Yeah.
Yeah, because we didn't yet discuss, right? Else that's not a big deal. Just reverse string and compare your original string and reverse string. That's all, friends. Suppose you have madam, reverse madam, you get madam. That is that is a palindrome. So only thing is we have to apply a reverse. If you want me, I can show you. Not a big issue. But again, the string is not discussed, right? That's why. The next thing is string only. There I'll show you. Again, I'll remind this logic with you. Armstrong, sorry, palindrome in strings. It's a simple thing. We don't have much to worry about that. Okay. So now, only thing is take a string, reverse it, and again compare that original string with reverse string. If both are same, it's a palindrome, string palindrome. That's all. So now, one more is Armstrong. I'm just trying to provide the logic of Armstrong. Logic means what? Suppose you have 153. I'm straight away taking a quick Armstrong number. If it is a 3-digit number, Armstrong logic is something like this. If it is a 3-digit number, then we have to find sum of cubes of digits of a number. Cubes of digits of a number. It's something like this. If it is 1 cube, we have to provide 1 cube plus 5 cube plus 3 cube. This is what we should do if it is a 3-digit number. Suppose if it is a 4-digit, we should not follow cubes of digits here if it is 4-digit, because earlier I used to think that Armstrong is sum of cubes. It's not sum of cubes. It changes, depends on number of digits in your input value. Suppose if it is a 4-digit number, you have something like 1, 2, 3, 4. Then what is that you should do? We have to find power of 4 of each digit. 1 to the power of 4 plus 2 to the power of 4 plus, okay, 1 to the power of 4 plus 2 to the power of 4 plus 3 to the power of 4 plus 4 to the power of 4. This is the logic we should apply for Armstrong. You got it right? If you have n digits, then you have to find power to the power of, so that digit to the power of n, and sum of that digit to the power of n's. You got it right, friends? Suppose if it is a 5-digit number, 1, 2, 3, 4, 5. What is that I should do if it is a for Armstrong? I have to say 1 to the power of 5 plus 2 to the power of 5 plus 3 to the power of 5 plus all this. You got it right, friends? So this is something you have to apply. You get this? For this, what is that you should do? You should know how many digits are there in this first thing. When you are working on Armstrong logic, suppose you got input from keyboard. Finding number of digits in this number is important. In this input is important, number of digits. If number of digits is 3, apply to the power of 3. Suppose if number of digits in that input is 4, apply to the power of 4. If number of digits is 5, apply to the power of 5. This is the pre-logic you have to implement before you go and apply that sum of, digit of power. So this is important. So when some input is there from keyboard, the first thing you have to do is finding number of digits in that number. Okay, the easiest thing is, easiest thing, because we didn't discuss strings, but I'm giving you an idea. Easiest thing is, so you can convert this to a string first. So to get length, I am saying, to get length, the simple and quick tip is, so convert this to, we didn't discuss that string thing. I'll show you even in strings how to work with this scenario. Convert number to string. When you convert number to string, applying length is very simple. Okay, just a quick conversion and finding length and get that length, that is enough. Okay, so this is something which we can do to get number of digits in that. But now we didn't yet discuss strings. What is the other way? I'll show you how to do that. In case if you are not up, still we didn't yet discuss about strings. So you take an input now. Let's do this now. Rest of the things are fine, friends. Because for getting iterative sum, all that is fine. Getting cubes is nothing. Just add power to that of digit. That gives you cubes are to the power of 4 or to the power of 5 or whatever you want. To the power of 6. Whatever you think is needed. Okay. Let's do this. I think you got the logic here. What is Armstrong here? Just quickly apply that. What do you do? Right click and then say new, and then Armstrong. Okay, test. So now you take again input here, some input number. Okay, input number equal to int of input. Now I want to find, as I didn't discuss this one string topic, I'm doing it with a manual approach. Even this also gives you how to find count. Even in strings, that how length function works, the internal logic of length is almost same what I do right now. So you have you get some input, right? I send it to temp just for in case if you want to use this value while printing or doing, right? Somewhere you want to validate. Copy it to temp. Now we are first getting length of digit without using any string or anything. How do you get it? Just take length, a variable length assigned to 0, length, okay? Assigned to 0. Now iterate loop while input number, okay, greater than 0. Just get the length here now, first length of that number, colon. So here you don't need to do anything, right? You just need to get length, length plus equal to 1. Increment every time loop iterates, increment by 1. And then what is that you should do? Simply you have to use input number equal to input number /10. And this should gives you length. How many hour times loop iterates? That should be the length of that number. You got it right. And now to find Armstrong, what is that we do? So we do one thing again. Temp has actual. By now, once this loop iterates completely, input becomes 0. So what do I do right now? I can start using temp now. So, or else you can also do one thing. Some temp1 equal to temp2 equal to. I'm copying same number for 2 times. This is chaining of values in Python. This is allowed. Temp1 and temp2 have same value. We copied from input number. So why I assign for 2 times? Because first time, this input number becomes 0, and second time to validate logic, and third time the actual value is used for doing actual validation. So now this gives you length. We just for quick test, print it. Okay, F double quotes the length. This is how length is even the inbuilt length function works. It try to iterate it and get the length of that particular number or data structure or anything, friends. The length of, so what is it here? Some temp1, because is simply just print length. Just run this now. Just give some 3-digit number or 4-digit, anything of your choice. Length of 1, 2, 3 is 3. Definitely it's 3, right? Again run this. 1, 2, 3, 4. Okay. And then press enter. Length of 1, 2, 3, 3, 4 is 4. We are halfway there, because this is something we need to get before we start applying the actual logic. Because Armstrong changes depends on size of digit. If it is 3 digits, we have to find sum of cubes. If it is 4, to the power of 4, sum of digits of digits to the power of 4, and it keeps continuing like that. So now what do you do? Copy this again. This time you don't need to find length. Okay, you can do one thing. This anyhow you can just remove this. I'm just giving you a step-by-step evaluation. So this is getting length, length of a number. Okay, and this is actually getting the core logic. So we are applying the core logic. So applying logic here. What is it for this one? It is so simple now. So get the reminder, of course, R equal to, don't use input number here. Better you use temp2 here, because input number becomes 0 in this iteration. Of course, you recopy temp2 input number, that is all there, but just to avoid unnecessary confusion, I just used temp1 and 2. Now I am using temp2, and here temp2 percentile 10. This has the actual value. Okay, and now the logic. What is that? And here just declare a sum variable before this, sum value, set it to 0. This is pre-initialization, and logic is sum value equal to some value plus. Suppose this is R. What is that I should do? R to the power of. So we have to apply power. Power of what? Is it R cube, R to the power of 4? What is that you should do? That you don't need to worry.
Length.
Length take care of that. If it is a 3-digit, just pass here length. R to the power of length. If length is 3, it gives you to the sum of cubes. Length is 4, it gives you that digit to the power of 4. Length is 5, it gives you that digit to the power of 5. So this just handles everything. Just whatever length you found, just apply to the power here. That's all. That gives you perfect palindrome thing. I mean, sorry, Armstrong thing. Okay, this is done, friends. So this is how we implement Armstrong. Now, finally, what is that? So here, finally, just doing validation. And the last step here is last leg in this Armstrong journey. What is that? Validation or Armstrong check. Finally, after doing all this, this is the one we just Armstrong validation. Okay, simple, right? By now you should be familiar with all this. If what is that? Use temp one. Temp one equal to. This is actually the one we should check for comparison. Some value. If that number, actual original number, okay, and then that sum of something, sum of that cubes are to the power of 4 or 5, whatever it is, if they are same, then it is what? Armstrong. So print F double quotes. The you can say here temp 1 is Armstrong. Okay. Else what? Else simply you can say not Armstrong. You don't need all this, of course. You don't need to. We never declare condition with else part. Even if with else, we need if again. Else temp is not Armstrong. And this should perfectly use us Armstrong for any kind of digits, any digit number, 3-digit, 4-digit, 5-digit, and we are just driving everything in one shot instead of having multiple versions for each type of digit, right? So run this now. Add this 1, 2, 3. This is a 3-digit number. Okay, there is a flaw in the logic. Yeah, what is the flaw? This is okay. Here, I should increment this with what, friends? Temp 2. So, with the actual flow, I put here input number. Here it should be supposed to temp 2, not input number. See, are you able to find this, friends? So that's why it's not working. So just a quick correction here. So here I'm again completely using temp2, which we have copied in the beginning itself. So when you use temp2 for validating this loop, then to work on this loop, then use for incrementing temp2, not input number. Anyhow, this input number becomes 0 in the first phase itself. This is phase 1, phase 2, and phase 3. Now this should work. So run this and say 1, 2, 3, enter. See, 1, 2, 3 is not Armstrong. Again, run it. You don't need to debug. We can avoid that. Run it again. So here, 153, a 3-digit Armstrong is this. You can see 153 is Armstrong. And maybe if you want 4-digit, 5-digit, you can just quickly Google it. Even I don't remember 4-digit, 5-digit Armstrong. 4-digit Armstrong number you can see here. For 4-digit Armstrong, you can copy from somewhere, friends. Anything should be fine. Just for testing purpose, okay? This anyhow. This is 4-digit. You can take this 1364. Okay, run this now. And you 1634. Enter. 1634 is Armstrong. Perfect, right? Suppose even similarly, you can take some 5-digit as well. Because if it is working for 3-digit and 4-digit, definitely it will work for 5-digit, no doubt. And okay, and you can see there are no 2-digit Armstrong numbers, just an FYI.
Just
All
one quick doubt. Here,
Yeah.
validation we have used into the temp 1 or temp 2? I think so, temp 2, right?
temp 2. Input number and temp 2. We use this both.
No, validation.
Validation we use temp 1 because temp 2 again becomes 0 by the end of this iteration, right? By when this loop completely iterates.
Got
It
it.
becomes 0, right?
Yeah.
That's why I try to preserve, copy this input number for two temps, temp 1 and temp 2. I am using input number for validation or to implement this length, and temp 2 I am using for finding actual sum. And finally, temp 1 is the actual value which is there without any, which doesn't go under any change. Is that okay? This doesn't undergo any change, so I use temp 1. Is that fine?
Yeah, thank you. Yeah, fine.
So that's it, friends. So finally, this is working version of Armstrong. We covered all scenarios here. Suppose if you want to test not an Armstrong, just give 1, 2, 3. This is not an Armstrong. Again, you give a 4-digit number 1, 2, 3, 4. Definitely this is not Armstrong. So even it is working for the other case as well. So this is how Armstrong works, friends. You got it right. So next, let me share that with you. So this is all about, I think we almost all covered the most core logics in programming, not just Python, friends. These are something really useful in any language. These are the core things. Why we discuss this? Not because we need any this thing, but the thought process, just to have a quick thought process on looping things. That's all. This gives you different ways of looping and all that. That is what the actual idea is. Hope you are good with all this, right? Still, if you have any questions or something, what we can do, you can, right, you can ask me or anytime if you think there is some confusion.